Hello everyone, my name is Abdoullah and I'm a PhD student in the Laboratory of Systems Engineering and Information Technologies. In this presentation I will talk about monitoring of physiological signs and their impact on the Covid-19 pandemic. Now we pass to the summary. I will begin with a little introduction, then I will list the objective of this method. After that, I will talk about the monitoring of physiological signs, discussion, and finally a conclusion. Recently, monitoring of physiological signs such as heart rate and respiratory rate is very important, especially when we are talking about pandemics like Covid-19. In this presentation, we will show the different techniques used for heart rate and respiratory rate extraction. This technique presented will be on image processing, where traditional sensor-based techniques creating a lot of problem at the contact level between patient and doctor. For this reason, we focus on non-contact techniques to avoid this problem. Generally, the literature review show that non-contact monitoring techniques are based on RGB, thermal, and multispectral cameras. The choice between these different cameras depends on the application that will be used. For example, thermal cameras are dedicated to the prediction of respiratory rate and temperature, while RGB and multispectral cameras are used for heart rate. The objective of this presentation is to show different physiological signs monitoring techniques and the impact of this contactless physiological signs monitoring technique on COVID-19. The human race has survived many pandemics. These pandemics, the common point between all these diseases is that all these pandemics were contagious with different degrees of risk. Healthcare system in such cases should be based on non-contact approaches to avoid any influence. That's exactly why from years ago to nowadays the world was merging into monitoring remote healthcare is an emerging research field as it is sensible. The PPG, also called photoplethysmography, is a low-cost, non-invasive tool that was proposed for the first time by Hertzman and al. 1937. This technique is a very now used technique in biomedical engineering, which gives good result in measuring heart rate, respiratory rate, and saturation. Thanks to its simple using manner and low cost, we found also the EPPG technique, that is the amelioration of the classical PPG technique. As you see in the picture, we have a light source that delivers the light to the skin, and we have the camera sensor that collects the change of the color skin. We have PK, the RGB channels of the skin pixel, ET, the illumination intensity level, RS the specular reflection, RD the diffuse reflection, IT modulated by both specular and diffuse reflection, Rn the quantization noise of the camera. Sanyal and al. In their work appeared in 2018 provides an approach for heart rate and respiratory rate remote monitoring, all based on measuring IPPG using Hue range 0 to 01.1 and not RGB channel. Thanks to its good accurate comparing to heart rate gain or respiratory rate gain, the algorithm was tested on a human face video frame of 20 seconds and 30 frames per second and applied only on 10 frames by using one image from every 3 successive frames, because this technique didn't affect the result, especially that the complete breaths are achieved within a period. The algorithm starts with detection the face and eyes using the HAR cascade-based detection function standing on OpenCV from every frame, and converted from RGB pixel into HSV in order to get hue values of the pixel. As you see in the right picture, we have the 3 blocks were the pre-person algorithm. All the steps mentioned before are considered as a pre-processing global step for the algorithm. Then comes the step of computing the average of hue in each process frame for the forehead, assuming that the region of front is the one where we can measure arterial pulsation. This block diagram contains some important steps, starting by the image acquisition block, which can be tailored using a smartphone camera or even UAVs. The essential thing is to capture the human body to get information to be treated in our image processing algorithm. Then comes image processing technique steps, which start with the region of interest. Selection is about selection of region of interest, such as the forehead, face, eyes, etc. The essential thing is to attract and detect the region we are going to get pulsation from. Then comes the raw signal extraction, which is a value compute by calculating. After we got the signal, comes the step of signal processing technique, starting by noise artifacts removal step. This step aims to remove all noise we got due to any camera motion, skin tone, or even illumination changes. After that, we proceed to the vital sign extraction, which is the main step we are looking for by using frequency analysis or peak detection, another use technique. In like manner, Al-Naji et al. 2016 came with a similar concept to detect and measure respiratory rate with a non-contact approach, as well as respiratory cycle timing parameters by using a video camera from the movement of the chest. The figure illustrates the approach proposed. Now we pass to the discussion in order to integrate all monitoring system into a single system that will monitor patients in critical cases and especially all people contaminated by the COVID-19 pandemic. We need a prototype that contains heterogeneous and homogeneous system that will help people to ensure good breathing. In this way, our proposed system consists of a camera that helps patients in enough oxygen and monitoring of heart rate, respiratory rate, as well as thermal camera that will monitor the temperature. Monitoring of vital signs such as heart rate and respiratory rate as well as temperature is a very important step for good diagnosis of patients. In this period and with the COVID-19 pandemic, we need non-contact monitoring technique to protect doctors from contamination. Integration of embedded system is in the biomedical field, especially patient monitoring based on non-contact technique. Embedded system with their variation, either heterogeneous or homogeneous, will give flexibility in terms of speed and real time. The implementation of vital signs monitoring algorithm in workstations and their validation using tools such as MATLAB does not give the hand to a real case study. For this reason, it is necessary to work on real patient cases. In this work, we have treated different proposed work based on different imaging sensors such as thermal and RGB camera. Thank you for your attention.